We're on our third part of the states of matter. We're talking about what is a gas. So what we're going to do is I'm going to read through some of the information here. If you want to try reading it on your own, you should pause me now so that you can do that. And then we'll talk about it and we'll do a little experiment and I'll show you some neat stuff about what is a gas. Look at the balloons. The balloons are filled with air. In this case, they're filled with carbon dioxide, probably from us. Air is a gas. A gas can change shape and size. A gas takes the size and shape of its container. Is that similar to a liquid or a solid? A liquid takes the size of it and shape of its container. You cannot see most gases. The air in the balloons can change into many shapes as you bend the balloon pieces. Look at how high the water is in the tank here. If you put the ball inside, it's a balloon, and you push the balloon in, notice how the water level rises. We're going to see what's happening there. And what we're actually seeing there is that this air is taking up space. So I'm going to perform a little experiment just to show you, and then we'll do something together playing with air. Okay, so we're going to get tricky again. If you want to do this with me, you certainly can. You don't have to. What I did was I filled a bowl. Oh, you can't really see the bowl. There we go. I filled this bowl with water, mostly almost to the top. You can see it's probably about that far away from the top. And now I have some food coloring. Make sure that you've asked if you can do this. And I'm adding it. Okay, and I'm going to use Mrs. Smith's version of a spoon. It's a pen. Okay, we got some blue water. All right. So what I'm going to do is I'm going to prove to you that air and gas takes up space. And what's going to happen here is I'm going to show you that there's air inside this cup even though we can't see it, and that it actually takes up space. And as I put my hand in there, I'm displacing the air. So what I'm going to do is going to put this paper towel inside the cup, okay? Oh, I need a bigger paper towel. Well, that tells you something. Okay, there we go. Okay, so I have my paper towel inside my cup. So if you want to do this, it's just a plain cup. I happen to use one I've already used before for another science experiment. And you want to make sure it mostly won't fall out. If it does, I'll just try it again because science is not perfect anyway. So what I'm going to do is I'm going to use the air that's inside here to displace the water. I'm going to put this cup in the water. I would like you to hypothesize or make a guess. Do you think that the towel will get wet? Well, let's find out. So what happens now is I'm going to take this, I turn it over so it's totally flat, and now I'm going to put it into the water. You can see I've gone into the water. My fingers are here in the water. Okay, it's underneath. All right, now I'm going to lift it back up. You can see it came out, the water came out. Here the water's dripping for the cup. Turn it over, and look at that. The napkin is totally dry. It would be blue if it wasn't. So what's happened there is the water could not penetrate inside the cup because the air displaces it and it pushes the water out. And actually, as I put this cup inside, the water level rises in my bowl. So you might want to try that at home if you, it's hard to see with my picture here. Now let's look what happens if I don't do it flat though, and I allow the air to escape from my cup as I put it into the water. If I allow the air to escape, and then I push it down, now not only does that fall out, but it gets totally wet. So that's how we do this. All right, so that just proves that the air is inside this cup, so much so that it displaces the water, the liquid, as I push the cup inside and keep the air trapped. If I allow the water and the air to escape the cup, then the water is let in and then it gets wet. Okay, so now I'm going to move this off to the side. So in case you're wondering, I did not spill it. Okay, now we're doing the assignment that I had kind of planned that you guys could join me with. So you need this paper. It says observing gases. And we're going to draw a force field and then cut out the rectangle. Okay, so there's my rectangle. And now I'm going to cut it out. You should do this with me. I'm going to glue this into my science social studies journal. So that's what this one is. And I just open up to the next available page. You can see science and social studies. Okay. And now I'm going to glue this to my book. I'm going to get a little closer to my book so that you can see it. Whoa, we got really close. It's okay. Okay, we're going to be performing a little experiment. You can watch me do this, or you can do it with me. Either way, you can watch me and then do it. Something you should definitely ask your parents about before you do this with me. Okay. So, let me fix the camera. I'll be right back. All right. So, our question is all about observing gases. And so, the beginning part of our sentence is going to begin with an I wonder question. So, it's something that you're wondering about. And what I can tell you is that it's anything you maybe have a question about gases and bubbles. So, why don't we write about, this is my question. I wonder about invisible, which means it cannot be seen, gas, and bubbles. And maybe how they interact. How is an invisible gas part of bubbles? What do we do in order to form a bubble? We have to use the gas in order to do something. Okay, so this is the explanation of what we need to do. So first we're going to draw what we need. Fill a tray with water. So draw yourself a tray. There's the water, and you should go get a tray with water. Pour some dishwashing liquid into the tray and stir. Okay, so we need the bottle of dishwashing liquid. Okay, and we'll pour some in, and then we'll stir it up, maybe using a spoon. All right, so you need those things. And it says use a straw, so we also need a straw. Okay, so there's my little straw. Now I'm going to create that. Here's my tray with water. Not that you can really see it, you just see creepy water. All right, there we go. Okay, now I need my liquid, my soap. I just poured maybe like 2 tablespoons. You can't really do it wrong except for making a mess. And now I'm just actually going to use my straw in order to stir. Oh, you can already see I got some bubbles. Okay, so what we're going to do now is we are going to use the straw. You're not going to suck in because ew, soap. What you are going to do is place it on the end here and gently blow. So I'm actually going to show you me doing that right now. The more gently you blow, and the more you can keep the straw inside the water, underneath the water, the bigger your bubble will get. And what's really neat is that sometimes you can put your straw right through your bubble. So you can go around. When we were doing this in first grade, it did make a mess. But what's really nice is that it's a mess with soap. So all you have to do is then use some water to get rid of the mess, and you have a really clean desk. So just make sure you're asking before you do this, and also be careful not to breathe in. All right, so we'll move that off to the side for right now. I hope you continue to play with it. And now we're going to be Mrs. Smith's other paper. There we go, and I'm going to come a little closer to my book. Okay, and now it wants us to talk about our data. So our data or data. So our data or our data, said the same word said differently, is how we found out and how we conducted the experiment. So the way that we conducted the experiment is we used a straw. And how do we use the straw? We blew air, well, not into, but through the straw. We blew air through the straw into what is located inside my tray. Is it a liquid, a solid, or a gas? Into the liquid. Period. Would your data change if you added more or less dishwashing soap? Well, let's look at it this way. If I didn't add any dishwashing soap, would there be any bubbles? No. You need the bubbles. You need the soap compound that creates the bubbles. And if you're washing dishes, for instance, and you want something to really fight like a grease stain on a dish, you have to add, I usually try to add more soap. So let's make a little equation. If we add more dish soap, what happens? More bubbles. And not just more bubbles, but maybe bigger bubbles. How big did your bubbles get? All right, so I hope you've enjoyed, and we're coming to a conclusion on our solids, liquids, and gases, and I can't wait to go through the next couple experiments with you. On Thursday, we're going to be doing an experiment in honor of Johnny Appleseed, and we're going to use apples. So you might want to have one apple that you can have cut up. Someone could cut it for you. You could buy apple slices, whatever you need. You could just watch me. But if you want to participate along with me, you're going to need apples, vinegar, baking soda. You need sugar, water, and lemon juice. Okay? All right. See you then.